Good morning or good afternoon. Welcome back. It's Miss Bauer here, and today we're going to talk about how to graph quadratic functions. So we've been talking about how to solve them, but now we're going to get into how do we graph them, specifically in vertex form and intercept form. So vertex form is f of x equals a times x minus h squared plus k. That's vertex form. And intercept form is f of x equals a times x minus p times x minus q. Notice that a is the same for both of them. Now, to find your vertex in vertex form, it's just going to be hk. That's it. So to find your vertex, it's just hk. Okay, very similar to what we did with absolute value. Okay, now over here, to find the vertex, you're going to add p and q together and then divide it by 2 because your vertex should be between your x-intercepts. Like it should be halfway between those. So that would be p plus q divided by 2. That's how you find the x part of it. And then to find the y part of it, you're going to take this and you're going to plug this back in for x. So that would just be f of, not x, but you would plug in whatever number you have. So p plus q divided by 2. And that's how you get your output or your y value. What p and q are your x-intercepts. So you have your x-intercepts. That's p0 and q0. And then your vertex should lie in the middle of those, which is where this comes from. Okay. Now, before we get too far into this, I want to remind you about your pink paper. Okay? And we're going to go through quadratic parent function really quick. Hopefully we were able to get to this, before I left the country. But just as a reminder, okay, your quadratic parent function is just f of x equals x squared. It's going to make a parabola. That vertex will be at the origin 0, 0. Your axis of symmetry is always going to be the x coordinate. So that would be x equals 0. Okay, domain, your inputs. Well, you could plug in anything you want to. So I would go from negative infinity to positive infinity. But when you do plug in those values, so if I come over here, my vertex would be at 0, 0. If I plug in 1, 1 squared is 1. If I plug in 2, 2 squared is 4. If I plug in 3, 3 squared is 9. But if I plug in negative 1, remember that negative 1 squared is also 1. Negative 2 squared is also positive 4. And negative 3 squared is also positive 9. So that's where we get our axis of symmetry from, around the vertex, because our values are going to kind of bounce back up. So my range would be from 0 to infinity. Now, your domain's never going to change, but your range could change because what if your parabola is going down? And that's what we're going to get into today, okay? Remember that 0 just means x-intercept. So that would be 0, 0. And my y-intercept is also going to be at 0, 0. Now, what makes your quadratics a little bit trickier is that we were looking at a v for absolute value, and that slope was consistent, right? If it was 2, it would go up 2 over 1, up 2 over 1, up 2 over 1. Or if it was 1, it would just be 1, 1, 1, 1. But now we have a quadratic, it's going to curve. So it's not 1, 1, 1, 1, 1, 1 anymore. I like to think of your table with these values. So when I start changing it, I'm always going to go back to this. But it's going to be 1, 1, 2, 4, 3, 9, 4, 16, and then 5, 25. And that's just because all of these values are going to be squared. So now instead of thinking rise over run, I like to think run, rise. Okay, so if I vertically stretch something by 2, now I would go 1, 2, 2, 8, 3, 18, okay, 4, 32. If I decided I was going to vertically compress this by a half, now I would go 1, 1 half, 2, 2. 3, half of 9 is 4.5. 4, half of 16 is 8. And this is what we're going to get into today, is how do you graph this, okay? And then how do you put that on the graph? And then what are the key aspects from that? So let's go back and let's take a look at some in vertex form, okay? And remember, whenever graphing, that you need to include a minimum of 5 points, okay? Think of your vertex as one of them. And then you essentially are just going to take your vertex, right? And I'm just making up something. And then if you go, that is your axis of symmetry, then you really just need to pick 2 points on the other side, and then you can just reflect them, and then there's going to be your 5 points, okay? So let's take a look here. Okay, my vertex would be at -2. Remember, this is the opposite. So this would be at -2, -1. Because your axis of symmetry is that x coordinate, that would just be x equals -2. Don't forget about the x equals because it's an axis. It's a line of symmetry going through there, right? Okay. Domain's going to be the same for all of them. You could plug in anything you want from negative to positive. So -infinity to positive infinity. Okay. But my range, if I were going to go and graph this, okay, and let's go ahead and graph it. I know that my vertex is at -2, -1, right there. And I know that my A is 1/2. So this goes back to that rise run thing that I was just talking about a second ago. If it was 1, 1, 2, 2 squared is 4, 3, 9, 4, 16, 5, 25, where this is your run and this is your rise, okay? This half is going to half all of these numbers. So from my vertex, I'm not going to go over 1 up 1 anymore, okay? I'm going to go over 1 up 1/2 because it was vertically compressed. I'm not going to go over 2 up 4. So I'm not going to go over 2 up 4, okay? I'm going to go over 2 up 2 because it was vertically compressed, okay? I'm not going to go over 3 up 9. It's half of it. I'm going to go over 3 up 4.5. So we're kind of doing run, rise, not rise, run, okay? And then I'm not going to do 4/16. I'm going to do 4. Half of 16 is 8. So I would go over 4 now, and then I would only go up 8. Now, if this is your axis of symmetry, I have several points already. I'm just going to reflect those across the axis of symmetry because it would also go left and up as well. And then I have enough to sketch out the parabola. These curves don't have to be perfect. It's kind of a pain even if you hold it down and then you try to like move it around, it gets really crazy sometimes. So they don't have to be perfect, but it does need to very clearly be a U shape, okay? So our range is at -1 going up to infinity. Okay, I can also get my range from this. If A is positive, your parabola is opening up. That means that you don't have a maximum for this function. You have a minimum at -1. And I know that from my vertex, and I know that because A is positive. So once you know your vertex, you really got down your axis of symmetry, and it's going to tell you your max and your min, which is going to affect your range, okay? Now, to find the y-intercept, I could look at my graph, right? But let's just pretend that you accidentally graphed this wrong. How could you for sure know your y-intercept? Well, remember that the y-intercept is just where x equals 0, and the x-intercept is where y equals 0. So if you go back up here and you just plug in 0, so you just find out what's f of 0, that'd be half times 0 plus 2 squared minus 1. Well, 0 plus 2 is 2. 2 squared is 4. Half of 4 is 2. 2 minus 1 is just 1. So your y-intercept, we're right. It's at 0, 1. Okay? And then our last question is, how is this a transformation from the parent function? We just saw our parent function originally. It was like this, right? Went over 1 up 1, over 2 up 4. But this didn't do that. That half made it vertically compressed. And you've seen this terminology before, so just don't forget that we're still using the same terminology. So vertically compressed, okay? And then it translates, don't say shift or slide, it translates, that vertex was at negative 2, negative 1. So this translates left 2 and down 1. Okay? And that's how we graph from vertex form. So let's take a look at another one. Okay? So right here, I don't see anything inside, like there's no x minus h squared, so that would just be 0 is my x coordinate. This plus 2 I know is going to move it up 2, so 0, 2. And you can kind of do these out of order if you want to. It doesn't necessarily matter, because I'm seeing this negative and I'm thinking that's going to reflect it across the x-axis. So I know that for a transformation, it's going to be going down now, reflects over x-axis. Hopefully that 1/3, you're thinking, that's going to vertically compress it, similar to what we did on the last one. And this one isn't translating right or left at all, but it is going to translate up 2 because of that plus 2 outside the parentheses. Okay? Now, your axis of symmetry is just x equals h because it's just the x coordinate from your vertex. So that would just be x equals 0. Okay? Our domain's the same every single time, negative infinity to infinity. And I could graph this to find the range, but I could also think about this. If this parabola is going down, because a is negative, that means that this parabola has a max, okay, at 2, that y coordinate, which means that if this is going like this and it's going all the way up to 2, this is starting down. So my range would be negative infinity up to 2, like that. And then to find the y-intercept, if I plug in 0 here, I get negative 1/3 times 0. That's just 0 plus 2. So my y-intercept is going to be at 0, 2. And I kind of already knew that because my vertex was there, and that is on the y-axis. So now let's graph this and verify that everything matches, okay? My vertex is at 0, 2. I'm not going up anymore, I'm going down. But I'm not going to go over 1, down 1. Remember, I'm doing run then rise. Now I'm going to go over 1, but I'm only going to go down by 1/3 because I was vertically compressing these values by 1/3. So I'm going to go over 1, down 1/3. It's okay if your points are between things. Like, it's fine because we've got fractions here. Okay. Now, for the next one, I could go over 2, down 4/3, or I'm going to go to 3. I'm going to go over 3. Well, what's 1/3 of 9? That's 3. So I'm going to go over 3, down 3, and that to me is a lot easier than dealing with 4/3. So I'm going to go over 3, down 3, because it's not 3, 9 anymore. It was vertically compressed, which kind of makes your parabola a little bit wider. And these aren't great pictures, but that's okay. And there's your parabola. That's it. Okay? Taking a look at a couple more in vertex form right here, I have nothing inside the parentheses again. So that's going to be 0. And then my k is negative 5, right? Okay. So I'm thinking like this 2 is going to vertically stretch it. I kind of like to do the transformation first, and that helps me with all of this, helps me with the graph, right? So the 2 is going to vertically stretch it. It's not translating left or right at all. It just went down by 5. So translates down 5. Okay. My domain I know is negative infinity to infinity. My axis of symmetry is going to go with the h, so x equals 0. If I'm not translating left or right at all, that would just be 0, right? Okay. Now I know that this parabola is going up. So that means that my vertex would be your min at negative 5. Okay, remember that your max or min is going to be the y coordinate of the vertex. So the max or min is the y coordinate of the vertex. Your axis of symmetry is the x coordinate of the vertex, but it's a line, so x equals, okay? Which means that my range is going to start at negative 5 because it was a minimum, and it's going up to infinity. And I already found my y-intercept. It was 0, -5, so 0, -5. So I'm going to start with my vertex. There's 1 clear point, okay? But I need 5. So like on the last one, I found 2 more, and then I just reflected them over. I'm going to do the same thing. But now I'm vertically stretching it by a factor of 2, which means that all your y values are going to change by 2. So it's not 1, 1 anymore. Now it's 1, 2. It's not 2, 4 anymore. Now it's 2, 8. It's not 3, 9. Now it's going to be 9 times 2 is 18, okay? So I'm not going over 1, up 1. I'm going to go over 1, up 2, because it was vertically stretched on each side. And then I'm going to go over 2, not up 4, but now I'm going to go over 2, up 8, because it was vertically stretched. And then I'm going to reflect that over to the other side, okay? And then because this one was vertically stretched, it makes your parabola narrow. Okay, this is why you want 5 clear points. My parabola is missing all the points, but that's okay because I have 5 clear points, so I know where your parabola is supposed to go. It's not like you can take your ID, and like I said, you can spin there. It took me a while to do that, so it's fine as long as you have your clear points. Get your U shape on there and you're good to go. I'm not going to count off as long as you've got clear points and you're pretty close to them, okay? And then let's take a look at one more in vertex form. Remember that your formula was x minus h. So this one would have a vertex at 2, 7. My axis of symmetry would be x equals 2. My domains, negative infinity to positive infinity every single time, right? Okay. Axis of symmetry at 2, that comes from that. Now, the question is your y-coordinate 7 the max or the min? Well, go look at A. If A is -3, that means your parabola is going down, which means that it has a max of 7. So because your parabola is going down, your range isn't starting at 7. If this is your max, then your range is starting at -infinity and going up to 7, your max. If it's a min, that's where your range starts. But if it's a max, that's where your range ends. So be careful with those ones, okay? Now, to find the y-intercept, I'm going to have to plug in 0 for x. So I'm going to do -3 times 0 minus 2 squared plus 7. So 0 minus 2 is -2. -2 squared is +4. But you had -3 out front. So what's -3 times 4? -12 plus 7 would be -5. But be careful. Don't just say -5. Don't say like your axis of symmetry is just 2. You want to be writing things as lines or points accordingly. So the y-intercept is a point. So I'm going to say 0, -5. Okay? And then I said you could do it really in any order. So that transformation piece can kind of go first, last, however you want to do it. You could just take this and even graph it and then answer the questions, okay? Up to you. But that negative out front made our parabola go down. So I'm going to say reflects. Don't say opens down. Say reflects over the x-axis. Okay? That 3 vertically stretches it. So think all those rise values are going to be times 3 now, right? Vertically stretched. And it's going to translate right 2 and then up 7. So my vertex is at 2, 7, which is right there at the top of the graph. And it's okay if you go off your graph by a couple, just like add a couple ticks up there and then put your point. Make sure it's clear. If that's the easiest point for you to do, then do it, okay? And it's going to go down, so be careful. And it goes back over here. I'm not going to go over 1, 1. This was all vertically stretched by 3. So this should be 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. Now I'm going to be way off my graph for sure, okay? But remember that you're not going over and up. Because this was a -3, I'm going over and down. So I'm going to go over 1, not down 1, but I'm going to go over 1, down 3 now. And then if this is your vertex, right, there's your axis of symmetry, so reflect it over to the other side. Okay? When in doubt, like highlight your axis of symmetry for your reflection. And then I'm going to show you something else in a second if you're having trouble as well. Okay? And then so over 1 down 3, not over 2 down 4 anymore. It was 4 times 3 because it was vertically stretched. So now you're going to go not over 2, 4. Now you're going to go over 2, and then 4 times 3 is 12. So now you're going to go over 2, and then you're going to go down 12. So that was 7, right? 8, 9, 10, 11, 12. So you're way down there at the bottom. And then you're going to reflect it over to the other side. And then you're going to sketch out that parabola. Like I told you, these don't have to be super pretty. Now, if you are having trouble finding points and you're having trouble with the vertical stretch stuff, once you know where your vertex is, just plug in other numbers to find it, okay? So if you have your vertex and you're like, I don't know where to go. Well, you need something over here, so plug in 1 for x. So back up here. If I plug in 1 for x, that would be h of 1, right? Equals -3, 1 minus 2 squared plus 7. 1 minus 2 is -1. -1 squared is +1. So that +1 times -3, that would just be -3 plus 7, which is 4. Well, look, wasn't that point at 1, 4? Okay. Now, to me, that's a much longer way to do it. But when in doubt, you can just plug in points and go from there, okay? Or you could have used your y-intercept as a point or your x-intercepts if you have those, which is what we're going to talk about in the next video. So we'll talk about intercept form in the next video. If you don't have your pink paper out, which hopefully you do, I would use this time to kind of get it out and just double check all of those formulas. And then I'll see you in the next one.